On February 7, 1984, 317 miles above Earth, Bruce McCandless pushed away from the space shuttle and into the history books, taking the largest first step in human history. While Neil Armstrong's small step was a giant leap for mankind, Bruce McCandless's first test of the Manned Maneuvering Unit was a plunge into infinity. Space is big. In size, obviously, but also in the way that it stirs our imaginations. The very concept of nothing is hard to fully process. And if space is anything, it's a whole lot of nothing. Potentially infinite nothingness. But at the same time, teeming with monstrous structures and energies beyond human comprehension. Filaments made up of thousands of clusters of galaxies, each with hundreds of billions of stars. Areas of space so dense and massive that the rules of physics entirely break down. And yet, when we look outside, we only see the very closest stars. All the rest of it is just out there, hidden in the endless darkness, like an eldritch horror. And despite that, or maybe because of it, we feel inexplicably drawn to it. From our earliest days, we explored the infinite darkness, looking for meaning. We used the stars to navigate, to guide our planting of crops. We imprinted our gods and mythologies into the patterns we saw in them. We may not have known what was out there, but we knew it was important. We invented eye-enhancing telescopes that reached through the darkness and found monstrous worlds we didn't even know existed. And now in the modern era, we've taken our first tentative steps into that void by packaging ourselves in suits and machines that simulate the conditions on Earth. And we can't survive in any of it. Our world, in this perspective, is a microscopic oasis in a never-ending inky void, as insignificant to the rest of the universe as a bacterium floating in the middle of the Pacific Ocean. Astraphobia is the fear of space, or astronomical objects. Astro from the Greek astron, meaning star, and phobia from the Greek phobos, meaning fear. So technically astrophobia is the fear of stars, but we include space and celestial objects as well. Objects like, say, the Mars moon Phobos. We literally have an object in the solar system named Fear. If someone from the city who rarely sees stars goes to the country or dark sky territory, they might find the immensity of a fully lit night sky to be overwhelming, even nerve-rattling. We might say that person has a touch of astrophobia. A believer in astrology might become nervous in the days when Mercury goes into retrograde. This could be considered astrophobia. Or the old idea that people go mad under a full moon, turning them into lunatics. That's astrophobia. In the ancient times, comets were thought to be harbingers of disaster. In fact, that's where the word comes from, dis-aster, bad star. But there's another type of astrophobia. One that's not specific to an object or a superstition, but something much deeper. A kind of cosmic existentialism. Have you ever laid in the grass on a clear night and just took in the sky? Just let it wash over you and kind of become a part of it. A strange sensation starts to come over you, that you're not actually looking up. You're looking down. Below you is a drop into an infinite void, and the only thing keeping you from falling is the fact that you're stuck to the ground by gravity. This shift in perspective is a bit of a transformative experience, and I recommend everybody to have it at some point in their lives. Certain chemicals can help that along, just saying. But that perspective is a bit more accurate. In space, there really is no up. There is no down. It's just out, in all directions, forever. And the only thing keeping you from falling into it is this invisible force called gravity, which we still don't really understand. And it's a good thing, because if you were to ever go out in any of those forever directions, you'd be dead after 5 miles. That's it. That is as far as a human can go in that direction before we can't breathe anymore. 5 miles. 8 kilometers. You could walk that distance in a little over an hour. That's nothing. And everything beyond that will kill you. Fear of space indeed. We exist on a tiny sliver of space, on the surface of a tiny planet. And even in that sliver, we can only survive on land, which is only 29% of the total surface. And even on that land, only 43% of it is habitable. The rest will kill you with oppressive heat, extreme cold, and choking forests. Earth can kill you in a million different ways. You can dehydrate, drown, fall off a cliff, get hit by lightning, consumed by fire, consumed by a lion, or a tiger, or a bear. You could eat the wrong berry, or pet the wrong snake, or get bitten by the wrong bug, or go to Australia. You could get blown up by a volcano, or breathe a toxic gas, catch a disease from a rat, or have a small number of blood cells clot up and travel to your brain, or just wait long enough. One way or the other, the Earth always wins. Nobody has ever survived Earth, and yet it's the only place in our solar system we can survive. If you teleported to the surface of Mercury, you would lose consciousness within 20 seconds for lack of oxygen, and in the vacuum of space, your skin would boil as gases in your blood flash into bubbles, like a carbonated soda. If you were teleported to the sun side, your body would bake on the 800-degree surface. If you're on the shadow side, it's immediate frostbite at negative 290 degrees. If you went to the surface of Venus, you wouldn't have time to suffocate from the lack of oxygen because you would immediately burst into flame from the 867-degree air temperature, while simultaneously being crushed by an atmospheric pressure 92 times higher than here on Earth. It would basically be like the Titan submersible, but on fire. On Mars, you might have a relatively warm day, but you'd still suffocate. There's only 1% of our air pressure there, and almost none of it is oxygen. So you'd get the worst case of the bends imaginable, and then pass out. Teleporting to the surface of Jupiter would be difficult because there's no real surface on Jupiter, just thick atmosphere that gets thicker as you go down until it turns into liquids and solids and states of matter we don't even understand. You would basically just fall until you were crushed into a diamond. Somewhat the same thing on Saturn, but breathing the ammonia clouds would scorch your lungs first. Neptune and Uranus are so far away from the sun that the hydrogen atmosphere freezes solid. That's why they're called ice giants, which is what you would be within seconds of going there. At negative 371 degrees, your body doesn't freeze, it vitrifies. Basically turns into glass. Our sense of scale about space is completely skewed because you can't really image it. To show it remotely at scale, you wouldn't really be able to see anything. It takes 8 minutes for light to travel from the sun to the Earth. It takes light about 8 hours to reach the outer edge of the Kuiper Belt and leave our solar system. So one light day is 3 times longer than the radius of our solar system. 1 light year is 365 times that long. Our closest star is 2.24 light years away. Polaris is around 450 light years away. The farthest star that you can see with the naked eye is V762 Cassiopeia, a supergiant star approximately 16,000 light years away. While we're looking at the Milky Way, we sit about halfway between the center and the edge. If we went to the edge, it would be 25 to 28,000 light years, making the radius of the Milky Way about 50,000 light years, roughly 100,000 all the way across. These distances are ridiculous, but that's nothing compared to the distance between galaxies. The closest galaxy is Andromeda, which is 2.5 million light years away, 25 times the length of our galaxy. We're part of the local group of galaxies, roughly 10 million light years across. And that is inside the Virgo supercluster, which contains 100 galaxy clusters and made up of 10,000 galaxies, spanning 110 million light years. And that is part of the Laniakea supercluster, including the Virgo supercluster and the Hydra Centaurus supercluster, that are all flowing toward a region known as the Great Attractor. It's 500 million light years across. Laniakea is one of the superclusters that makes up the Pisces-Cetus supercluster complex. It's a galaxy filament a billion light years long. At this scale, the cosmos breaks down into filaments and voids, including the Boötes void, which is 300 million light years across. Just pure emptiness. Beyond this is the cosmic web, which is where our numbers break down. All told, the observable universe is agreed to be about 93 billion light years across. Given the absurd scale that we're dealing with, one can only assume that the universe is filled with billions, even trillions of different planets harboring life. If there is even a millionth of a percentage chance that life could evolve in another star system, the number would still be, well, astronomical. Arthur C. Clarke once said, quote, "Two possibilities exist. Either we are alone in the universe, or we are not. Both are equally terrifying." If the universe is teeming with life, that would mean that it's filled with potential hidden threats all around us. But it would also mean that we are not special. We do not have some privileged place in the universe. We are not the universe experiencing itself. We're just a really weird fluke of organic chemistry that happens from time to time, devoid of meaning and purpose. If there's no life outside of Earth, then we are truly alone, floating in an infinite void, which would be, in the words of Ellie Arroway, a huge waste of space. It's such a waste of space, it feels unreal. Perhaps a simulation? What if this really is just a massive game that creates itself as we explore the virtual universe? The further out we look, the more we see. When Hubble took its deep field photo, pointing at a tiny dark patch of sky and finding thousands of galaxies, maybe those galaxies literally didn't exist until we looked there. Maybe the structure of the universe didn't exist until we figured out how to map the cosmic microwave background radiation. Maybe you and I are just ones and zeros, and what we experience as consciousness is just a sim program, just existing in a game. This is a popular theory, if maybe a little bananas. But belief in it is understandable, considering the equally baffling absurdity of the physical universe. There is a more elegant solution, though. One that allows for a universe teeming with life, but simultaneously seemingly void of life. But it's no less existentially terrifying. The term Great Filter speaks to the idea that basic life like single-cell bacteria might be common, but intelligent life encounters barriers that prevent it from existing everywhere. Some think the Great Filter occurs before intelligent life. For example, the evolution from single-celled organisms to multicellular organisms, that might be a Great Filter. After all, the Earth is 4.5 billion years old, and single-cell life began relatively early, some believe around 500 million years. But it wasn't until 1.6 billion years ago that multicellular life arose on Earth, meaning it took 2.5 billion years for life to make that jump. Perhaps this is such a remarkably rare event that it could be considered a Great Filter. Others suggest the Great Filter is something that still awaits us, that it occurs after intelligence evolves. Maybe because of a cataclysmic cosmic event, or the death of their star. Maybe it's a predatory alien civilization engaging in dark forest gamesmanship. Or maybe because intelligent civilizations inevitably drain their own resources and wipe themselves out. Perhaps intelligence isn't the ultimate goal of evolution, but a mutation of it, a kind of cancer, a metastasis that requires an unsustainable consumption of resources that inevitably dies out. All of this is an overdramatic way of saying that maybe intelligent civilizations have a time limit. And if there's anything as absurd as the space in the universe, it's the time of the universe. The two are fundamentally linked after all. The average lifetime of a species here on Earth is between 5 and 10 million years. Intelligent life might fare better, or it might fare worse, but we can give ourselves the benefit of the doubt. Let's just say we last 10 million years. In the 13.8 billion year history of the universe, that is a line so thin, you can barely see it on the screen. Even if life was common, even if intelligent life were common, even if every single star system in the universe were capable of creating intelligent life at some point before that star system dies out, it is entirely plausible that all of those civilizations rose, conquered, and ended at different windows in the universe, and never knew that any of the others ever existed. We, in our tiny, inconsequential oasis of the universe, are only here for a fleeting amount of time. And all we have is each other against the vast, consuming darkness. On Valentine's Day in 1990, the Voyager 1 spacecraft, well past the orbit of Neptune at this point, took one last look back toward the inner solar system and snapped a picture. This picture held no scientific value. In it, there was nothing we could learn that we didn't already know. But in this photo, Voyager captured Earth from over 6 billion kilometers away, making it look like only a cluster of blue pixels. Carl Sagan championed this photo and called it the pale blue dot. It is, in a sense, the most accurate photo of our species ever taken. In Carl's words, "From this distant vantage point, the Earth might not seem of any particular interest. But for us, it's different. Consider again that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors so that, in glory and triumph, they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe, are all challenged by this point of pale light. Our planet is a lonely speck in the enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit, yes. Settle, not yet. Like it or not, for the moment, the Earth is where we make our stand. It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known. Space is scary, and yet we are drawn to it. It's the ultimate call of the void. And with a renewed interest in colonizing the moon and new telescopes like the Vera Rubin telescope, we seek to expand our reach into the abyss. And maybe we'll get there. Maybe we'll wise up and outlive our species' life expectancy. Maybe we'll expand through the cosmos and find new homes on other worlds near other stars. Because in an infinite universe, anything is possible. The expansive scale of our universe is beyond comprehension, but your comprehension skills are not beyond expanding when you dive into the scientific thinking course on Brilliant.org. Over 40 lessons and 480 plus interactive puzzles, you'll learn valuable insight into how our world works, as well as the technology that makes our modern way of life possible. Everything from gears to optics to the physics of pool shots, each lesson is taught by engaging your problem-solving skills to solve puzzles and games. And that's just one of dozens of courses spanning math, computer programming, data analysis, AI, and science, from beginner levels to advanced material you never thought you'd be able to understand. It's a totally different type of learning than you had growing up, and it makes the lesson stick because you're not relying on rote memorization, you're figuring it out the way that makes most sense to you. Best of all, it doesn't feel like studying or like you're being forced to listen to a lecture, it just feels like you're playing a game. If you're anything like me, you probably have a few games you pull up on your phone to pass the time, and you probably spend way too much time on it. But with Brilliant, you can spend that time actually learning something useful while still getting that nice dopamine hit you're used to. You can do it on your phone or online, or you can download lessons for those times when you don't have access to the internet. To get started, just go to brilliant.org/answerswithjoe. There's a link down in the description, or you can scan the QR code on screen right now. You can try it out for free, and if you sign up for the premium subscription that gives you access to all their courses, my viewers will get 20% off the annual plan. I love Brilliant. I've been using it for years, and I can say it just keeps getting better. So go see what you've been missing. The link is down in the description. Thanks for watching, everyone. Spooky season is upon us, and I thought, why not kick things off with the scariest thing I can think of: existence itself. If you're a regular viewer, you might be thinking this was something different, and it is. I thought I would just do something a little bit different this time. I don't know. Let me know what you think in the comments. If you're new to this channel, I invite you to check out some other videos of mine. I'll put one on the screen here. And if you like them, I invite you to subscribe, because there will be more videos to come. So until next time, go out there, have an eye-opening week, stay safe, and I'll see you next Monday. Love you guys. Take care.